Hello, today we will talk about a topic that I have been posted several days back. It's about the molecular simulation and the usage in several applications. And today I picked the topic for sure it's my favorite topic. It's the polymerization. So today we will see how to do the molecular simulation for the polymerization. So as you can see here, this is a software developed by the University at Buffalo. This is the University at State New York. And there are several other applications, as I mentioned before, that like GrowMax or Nomad, but today we will go through this software and see the options that we have here. So as you can see here that we have the first tab, which is the configuration. It's showing the molecules, and you can see here that we can set the temperature. So I'll keep it at 300 and I'll keep the system isothermal. And for the number of molecules, we'll go the next control that we can do for this one. We have the monol and the mono acid, and we have the diol and diacid. And actually, this mono and the mono has only one function, the di has two functions. So today we will talk about only the monomers, which has two functions, so it can connect or it can bond with two different molecules. So we will have the diol and the diacid. This is the dicarboxyl acid, and the diol, it's like more like alcohol or something like this. So let's put here the number of molecules around 300. You can see that the red dots has increased, and let's put the blue dots or the diol 200, so we will have a ratio about 3 to 2. So we are expecting that we have red dot, blue dot, then red dot, then blue dot, then red dot, because the reds are more for sure. For the crosslinker or the crosslink function, I'll keep this later on because this will take us to another subject, which is the gel formation or the gelation. I'll do some separate video on this one. And then let's go for the reaction energy. So let's put that one on the maximum at 40. This is the kilojoule per mole of the diol, which is as I mentioned, it's the oxalic acid. And the fraction of heat transfer to the solvent, if we have a solvent. So today I'll not add any solvent, so we'll keep it as it is, 0. So there will be no heat transfer to any other the environment around the reaction, so the system kept adiabatic. So let's start the simulation and see what will happen. As you can see here, the molecules start to bond to each other. And just one thing that I need to highlight, that this software or this simulation is not considering any chemistry. It's only considering the forces and the bonding between the molecules. You can see here they start to have like the bonding. Let's see the matrix. This will show to us here we have the simulation time in femtosecond, and this is the measured temperature. So trying to adjust around the 300. We will go to the temperature profile and see it. And here the average molecular weight, the number average molecular weight, you can see it is 5, because as I mentioned we have 300 of the red dots, 200 of the blue dots. So overall each chain will have like 5 molecules. So the average molecular weight, which is, it can be used as the number of molecules here in the software, or we can represent it as the average molecular weight. It will be 5. Temperature, let's go to see the profile temperature. As you can see, wow, it has a huge jump at the beginning because we didn't consider any heat transfer. So at the beginning, this is the initiation temperature. It jumped it over and then return it back to the normal temperature setting, which is around the 300. And after that, let's see about the composition. You can see here the chain length over the time. Let's look at the molecular weight. As you can see that the number average molecular weight, which is the blue line, and the weight average molecular weight, which is the yellow line, at the beginning of the reaction they start to increase, and it depends on the the kinetics and the rate of polymerization. It can be very quick or very fast reaction rate, or it can be slower. So as you can see here, and then it will settle down at 5. This is what we have. It will not increase anymore. And also we don't have the chain, or we don't have the cross linkage in between the chains, so it will be as it is. Here the conversion, it should show some graph, but maybe because of my laptop system is not supporting this one. But anyway, we can just right click and copy the data. Let's take the diol conversion, and we can go here and just you can easily paste the data for the simulation time. You can do some graphs, you can do some calculations, you can do some comparison between different setups. I'll go back to the model. As I mentioned, that you can like do some simulation at certain temperature and then repeat the simulation at another temperature and compare between them. As you can see here, the chain is growing, and you can see that there will be some still excess red dots, which we have it, and you can see that there will be some small chain, which is the trimer and maybe dimers, and we will have like the 4 molecules together, which will be the oligomer, and then we will have long chain of the poly. I think in the next videos we will talk more about the options and the software, and we will talk about more the gelation, and it has another module for the some other things like the can be showed here. Let me show you. It has some on absorption, it has some module about the catalysis, it has some module for the free radical polymerization, which I think we should talk about this one, some chemical potential, nucleation, osmosis, and many other things. It can do the simulation for it. So thank you for watching this video. I hope that you learned a new thing today.